Welcome back, pre-algebra students. We're in lesson 116. We're going to talk about how to find the area of parallelograms and trapezoids. So we've already been finding the area of rectangles and squares and the area of triangles and also the area of circles. And these are the formulas that we have below. The area of a rectangle is, or a quadrilateral, is base times height. The area of a triangle is the base times the height divided by 2. And the area of a circle is pi times the radius squared. So those are all the ones that we are familiar with so far. But now we're going to find how to find the area, or we're going to discuss how to find the area of a parallelogram. So let me clear this page for you. And I will draw you a parallelogram as close as I possibly can. So here is my parallelogram. There we go. And let me adjust it just a little bit. It's not quite parallel. There we go. That's pretty close. So just give me a little margin of error. Technically, a parallelogram is supposed to have two pairs of congruent and parallel sides. So this side is parallel to this side and congruent to this side, and this side is congruent and parallel to this side. And that's our parallelogram. So here is how we would find the area of a parallelogram. You're looking at me or looking at the screen and probably thinking to yourself, how are we going to find that? Because it's all slopey. What do? Make a triangle and a triangle? How does that work? So let's look at this one. This one has a length of 6 here. This side does. This side has a length of 4. But in order to do this accurately, we need to know the height of the parallelogram. So the height of this parallelogram is 3. And we're going to say this is in inches just to make it easy. So what I would like for you to visualize, I'm going to change color here, and I'm going to draw a little triangle right on top of this one. Hopefully it will let me draw that. It's not going to let me draw that. So let me undo that. Let me try it again. It's my mouse. It's giving me a hard time not wanting to stop when I want it to stop. There we go. All right, so let me adjust the shape for us just a bit. There we go, this shape right here. I want it to be exactly what this one is. I need this to be exactly straight up and down so that it can be perpendicular to the top and the bottom, so you can see the relationship there. All right, so imagine I took this portion of the parallelogram and I cut it off and I move it to this side. What do we have now? If I had drawn this perfectly, this little portion that we cut off would have moved over here and it would make a rectangle, would it not? If this were the little line right here that we had sliced it away, taken this half and moved it over here, we'd have a little rectangle, right? How do we find the measure of a rectangle or the area of a rectangle? We take the base times the height, right? The height is 3. The base is 6. So we can take the same measurement for a parallelogram. We take the base times the height, and that's going to equal the area. We just have to be careful when we do that we don't try and confuse the height with the length of this side. The height is different because this side is at an angle. It's not straight up and down, so it's not a true height. It's at a diagonal to the actual height. So we need to have that third dimension here of the height. We don't even need the length of the side. All we need is one of the bases and the height of the other side. And then we can find the area. And here, that is going to be 6. Well, let me get back over here on my pen. That's going to be 6 times 3 inches is going to be 18 inches squared. And that would be the area of this parallelogram. See how interesting and cool that is? That was not hard at all, and it's not far off from what we were already doing. So let's look now at a trapezoid. It's a little bit different. Let's erase all of this, but remember that a parallelogram, remember 2 L's are parallel in parallelogram. The area of a parallelogram is the base times the height, but you have to be very careful about which one is the height. Okay? All right, so let me clear all of this off, and we will talk about how to find a trapezoid. So let me draw a trapezoid for us. This is a trapezoid. And then I'm going to have to adjust it just a little bit. Well, maybe not. That looks pretty good. So a trapezoid is a shape that has one set of parallel sides, and that's basically it. It's a 4-sided, it's a quadrilateral with one pair of sides that are parallel to one another. They're not the same. They're not congruent in length. These two are not parallel, but they are typically congruent in length in most of our trapezoids, but they don't have to be. They do not have to be congruent. They are not parallel. The only requirement is that one pair of the sides be parallel. In this case, we have a length here of 6. Again, I've got to get my pen. The length here is 6. Put that back if I can. I didn't. Try it again. There it goes. All right, and the length here is going to be 9 on the bottom. All right, now what you do need to have in order to find the area is the height. And in this case, I'm going to draw the height in for us. And the height of this trapezoid is 4. So here's how you find the area of a trapezoid. Remember the area of a triangle. Remember how we said the area of a triangle equaled the base times the height divided by 2? The easiest way to find the area of a trapezoid is to take a diagonal and split it into 2 triangles. Now we have area 1 and we have area 2. We have 2 triangles. So we take the base, which in this case is going to be the top, but it is the base of this triangle, and then we have the height. So area 1 here, we're going to take the base of 6 times the height of 4, and we're going to divide it by 2. 24 divided by 2 is going to be 12 inches squared. That's the area 1. And we're going to take area 2. We have a base of 9 and a height of 4. So 9 times 4 divided by 2 is going to equal 36 divided by 2, which is 18 inches square. And then just like we normally do, we add those together and we get 30 inches square is the area of this trapezoid. So all you need in order to find the area of a trapezoid is the length of the 2 parallel sides and the height of the trapezoid. And then you draw your diagonal between the 2, making them triangles. And it doesn't matter which corner you draw. You could do it from this side to this side. You would still have a base of 6 and a height of 4 and a base of 9 and a height of 4, even if you drew it from the opposite corner to the opposite corner. So that is how you find the area of a trapezoid. And that is all we have for this lesson, is the area of a parallelogram and the area of a trapezoid. I do want to point out one thing. We have been finding the area of this shape right here by creating a triangle. Let me get my little pen. We've been making this a triangle, right? Let's say this was 6 and this was 9 and this was 4. Those are the same dimensions we have here. We know now that all we ever had to do, let me use a different color, was make a line here and turn this into 2 triangles, because this technically is a trapezoid. We have 2 sides that are parallel to one another with 4 sides, which is the definition of a trapezoid. So we could have said 6 times 4 would have been, divided by 2 would have been 12, and 9 times 4 would have been 36 divided by 2, which is 18, so that would have been 30. But if we had done it the old way, we'd have said 6 times 4 is 24 for this interior rectangle, and then we would have found the difference here, and this would have been 3, right? Because 6 from 9 is 3, and it's 4 tall because this side is 4 tall. 3 times 4 is 12 divided by 2, which is 6. 24 plus 6 is 30 inches squared. Look at that. Is that not the same thing? When you don't have right angles here, it does make it harder, but this is how you do it. You just turn 2 of them into, you turn them into 2 triangles. And so now you have another way to determine the area of a trapezoid that looks like this with right angles. It's whichever way you want to do it. But with this one, you don't really have a choice. You really need to turn them into 2 triangles and use that method. And that's finally all I have for lesson 116. And we'll see you in lesson 117.